Let's keep the thing in perspective. Um, in this slide, again, I will discuss the visible and invisible range. Um, so we are comparing the structure which is known to us and in the visible range to the structures or bodies or objects which are invisible. So if you can see a circle on the top left hand side of this slide which represents a diameter of a normal human hair. So the diameter of this circle is about 100 micrometer. I'm not saying the actual size of the circle, just I'm telling you about the diameter of hair, which is the hair of a normal human being is about 100 micrometer, and just I'm drawing the diameter of a normal human being hair as a circle, which is on a much bigger scale on this slide. So let's assume if this circle represents the diameter of a normal human being hair, so the bacteria which is the size of 10 micrometer will be a ball, a shaded red ball, and definitely the size of red shaded ball is much smaller to the size of normal human being hair. So the hair is visible to us and the size of hair is nearly 100 micrometer, whereas bacteria size is about 10 micrometer and it is in invisible range to naked human being. So naked human being eye, sorry. Similarly, the road dust particles, they are nearly impossible us to see them, so they are in the range of 5 micrometers. Similarly, the coal dust particles, they are about nearly about 2 micrometer. They are floating in the air because of their lightweight. Similarly, if you can see the virus, the size of virus, which is about 0.4 micrometer, and in this slide it's just represented by a dot as compared to the circle which is representing the human hair. So the size of virus is so much small, as teeny as dot, if you compare to the size of hair, which is a big circle. Similarly, the vehicle emission is about the size of 0.2 micrometer. So it's again is a smaller dot than the virus, but we cannot see them. The scale drawn on the right hand side, on the top right hand side, is just to mention the relationship between the sizes that I have shown you on the left hand side. So what is a centimeter, what is a millimeter? So just to visualize the things in the easy way, um, I took the scale that we also call ruler, which we are using in daily routine. So as I mentioned, the hair, a big circle. If we can see this big hair, not a big hair, it's just a hair, normal human being hair, by scanning electron microscopy, and then the things that are visible to us by naked eye is totally different if we visualize the object under scanning electron microscopy. Normally, if you feel the hair of your head, that if you feel it, then the surface look like very smooth and slippery, but in reality the skin is the outer skin of hair is not smooth as we feel. Actually, it's the outer skin of hair is just like a scales. um, if you see the fish skin, it has scale on it. So the outer skin of hair is very much similar to the skin of fish. So it has scale on it for the protection purpose, and then inside the hair there is a complex structure. So there are some other stuff made of cells. So the hair, which is look very simple and naive by the naked eye, is not simple um, in principle, but it's made of number of stuff or number of cells. um, so the things are becoming very interesting if we see these objects under like sophisticated equipment. As an example, scanning electron microscopy. So the bottom left image is taken by the electron microscopy, scanning electron microscopy by the magnification of 1200 as compared to the normal. Whereas the size, as you can see, the line, a bar, this represents a 10 micrometer. So if you multiply this 10 micrometer by 10, then you will get the diameter of this hair, which is nearly 100 micrometer, as shown on top right hand side of this slide as a big circle. So the things that look very simple and naive by the naked eye are not simple. They are complicated structures, um, and this complicated structure behave differently if we view them by the scanning electron microscopy. So now we are on the topic of today's discussion. What is scanning electron microscopy? So to define scanning electron microscopy, um, we can see that by this equipment we can see the objects which are in the range of 1 micrometer to 1 nanometer. How much is 1 micrometer? 1 micrometer is the thousandth of 1 millimeter. 1 millimeter can be seen by the visual eye, but 1,000th of the millimeter is impossible to view by the naked eye. So 1 micron to the 1 nanometer, which is the size of atom, we can see this range from micrometer to the nanometer by this very beautiful equipment named as scanning electron microscopy. So the size can be correlated to the number of times or magnification you can view. So you can magnify the objects under observation by scanning electron microscopies from 10 times to 300,000 times. So 300,000 is a big scale. So you can visualize the things which are very small by the help of scanning electron microscope. There are a few terminologies that we'll be going to discuss in scanning electron microscopy, and the terminologies may be you already heard about them, like resolution, depth of field, or microanalysis. Resolution and depth of field, normally people use these two terms in photography as well. So what is resolution? So resolution means that you can distinguish the boundary line of two similar objects placed together. Again, to keep the things in perspective, there is a image of flower on top right hand side. So there the image of 4 flowers in a single slide is separated by 2, the left hand side and the right hand side. Left hand side, it's bit difficult to visualize or to see the flowers at the back side, whereas The right hand side image, you can a bit you can distinguish the four flowers a bit easily. So we can say that the image of the flower at the right hand side has better resolution as compared to the image at the left hand side. So this gives us a thought about the resolution. So resolution is nothing but it can defines or distinguish the objects which are uh, closely packed to each other. The second term is the depth of field. So depth of field means that um, how much uh, how much easily you can visualize the height of an object um, uh, by seeing the image. So in case of SEM, if there's a depth of field terminology, then it means that how easily you can imagine the height of an object. As you can see, there is a SEM image of some nanorods. Um, so there are so many thin bars that are protruded in this image. So you can see that these bars has certain height. So this certain height is normally um, observed by SEM, and we can term it as a depth of field. The interesting thing that I have to share about SEM right now is that normal SEMs, they scan the object in the 2D scale. So by SEM we cannot see the objects in the third dimension. The third dimension is the depth. So you can just visualize the surface of any object, not the depth. But the interesting feature of SEM is that you can you can visualize the depth of some object, but the depth is not the true depth, because in principle SEM the SEM as a tool, we cannot see the object height, we can only see the object surface. So if you see you can see the things as a like the height of something. So the height of something in the SEM, it's normally referred to as a depth of field, but the height will not be a true height. I hope you understand this topic right now. If you have confusion, then definitely in the later lectures, when we are going to discuss the SEM in more detail, then you will understand what I mean by the depth of field. But in principle, you have to remember that by normal SEM, we can visualize only surface of an object or a specimen. If we want to see the specimen surface nearly in detail, then we can see the surface by using scanning electron microscopy. But we cannot see the how much height of this object is in the scanning electron microscopy by the help of a scanning electron microscopy. But to some point we can feel the height, but just you can feel the height. The image taken by SEM will not give you the 100% that how much the height of object is. Just as these nanorods, you can see the nanorods, they have some height, but you cannot 100% say that how much height of these nanorods have. These are the nanorods which has some height, but you cannot say 100% that how much height of these nanorod may have. Similarly, there is another terminology we will be using in the scanning electron microscopy. It's called microanalysis. Microanalysis means that you can know the composition or chemical composition, crystallographic arrangement of um, um, uh, the arrangement of different atoms or molecules inside the structure. So by coupling the scanning electron microscopy with a tool called EDX, so if we couple the normal scanning electron microscopy with another tool called EDX, we will discuss it later. Then we can also analyze the composition as well of the structure. This structure is made of iron, gold, or oxides like cerium oxide, um, magnesium oxide, calcium oxide, whatever it is, and how these structures are arranged in this object. We can also analyze by the microanalysis tool. So these three terms we will be using very much in the scanning electron microscopy technique. The resolution, which means how easily you can distinguish two objects which are closely packed to each other. Second is depth of field. You can visualize the height of an object, but it will not give a true height. And also you can see the composition the structure. The structure are made of which things. You can also see this composition by the scanning electron microscopy. If we couple an additional tool to the scanning electron microscope, which is called EDX.